ligand is introduced, equilibrium will shift. Now this T2 will act as a reservoir of protein. Now the arrow 2 can bind to the ligand. So if we look at it before, we have something like this: arrow 2, T2. This is when they are in equilibrium in the absence of a ligand. The moment we introduce a ligand to it, there will be a shift in equilibrium whereby the T2 will now act as a reservoir of protein, while the arrow 2 will be here, so that it can bind to the ligand. And the ligand is anything that can bind to an enzyme or a protein, irrespective of whether it is a substrate or not. So here will now be arrow 2 plus S to give us arrow 2S. Another S binds to give you arrow 2S2. Now at this point, the arrow 2 plus S give you arrow 2S. Arrow 2S plus S give you arrow 2S2. Now we are told that Kb is equal to 1 over Kr. This Kr means intrinsic dissociation constant. Now let's start from the first one. Based on knowledge of prerequisite, using this equation, the prerequisite Kb1 is equals to arrow 2S over arrow 2 and S. Now by the time we cross multiply, we now have arrow 2S equals to Kb1, arrow 2 and S. Now we want to get the Kb1. The Kb1 equals to 1 over Kr times the number of protomers forward over the number of protomers backward. So the number of protomers forward is 2, which is what you are seeing here. The backward is 1. So 1 times 2, you have 2 over Kr. Now coming down to here where arrow 2S is equals to Kb1, arrow 2 and S. So now here now, the Kb1 now will now be replaced with what? 2 over Kr. So here will be 2 over Kr. Here we'll have arrow 2. Here we'll have S as your arrow 2S. Now coming to Kb2, the Kb2 will have arrow 2S2 over arrow 2S and S. Now you cross multiply also, having arrow 2S2 equals to Kb2, arrow 2S and what? S. Now we are going to get our Kb2. Kb2 equals to 1 over Kr times the number of protomers for arrow 2S2 forward. This is arrow 2S2 S. Arrow 2S2 forward is 1, backward is 2. So you have 1 over 2. Now 1 times 1 gives you 1. Kr times 2, you have 2Kr. Now coming down to this place, arrow 2S2 is equals to 1 over 2Kr times this arrow 2S now becomes 2 over Kr, arrow 2, S, and this last S that is here. These two will cancel 2. So we are left with arrow 2S equals to 1 over this Kr times Kr square. We have arrow 2, S times S give you S square. Now that we have gotten to this point, the next thing we are going to look at is fractional saturation. We are getting close to the last part.
And this one is just for dimeric.
Dimeric, yes. Don't worry, at the end of the day, I'll give you the general formula whereby you can know what it will look like for any other one. So, right, so.
Are we writing all these many things in exams?
Yes.
Yes, now. If it's not in exam, why are we doing it?
You write it.
Am I here to play?
How do I know what you are doing? You just have to go to
So, the fractional saturation will now be. The fractional saturation is complex over total enzyme.
Is it the Y that is representing the fractional distribution?
Yes. So the complex we are going to have arrow 2S plus 2 arrow 2S2. These are the complexes. Now why here is arrow 2S is because it's only one of the protomer that bind to the ligand. Why this one is 2 is because the 2 of them are bind to 2 ligands. Now over when we talk about total enzyme, it consists of both the free enzyme and those complexes. Now for the fact that it's a dimeric protein, we will now have something like the 2 arrow 2 plus 2 arrow 2S plus 2 arrow 2S2 plus 2 T2. You add this T2 to it because the T2 is also a reservoir of protein. So add it to it. Now on getting to this point, something will happen. We are going to be replacing them, the arrow 2S, with all this. But before we do that, I told you something about when the arrow 2 is in equilibrium with T2, there is always an allosteric constant called L. And we say the L is equals to T2 over arrow 2. I said something is in your notes. L is equals to T2 over arrow 2. We now went further to cross multiply, saying that T2 is equals to R root 2L. So for that reason, this place here will change. We will now have something like this. Y is equals to R root 2S plus 2 R root 2S2 over 2 R root 2 plus 2 R root 2S plus 2 R root 2 S2 plus 2 R root 2L because of this. Now at this point, we are going to be substituting this for R root 2S and this for R root 2L.